Hi, my name is Rohit Kumar. Today we will discuss New York taxi trip duration project. In the streets of New York City, millions of taxi trips are taken every year. But what if we could predict the duration of these trips? That's the focus of our New York taxi trip prediction project. Our journey begins with a deep dive into a massive dataset containing approx 1.5 million records. Let's join us on this exciting journey to optimize the world of taxi services. Let's move to Google Colab. First, I collected my data from Google Drive. Then I process to do some EDA to visualize in chart. Then I split my data into train and test data. To train the model, I select 5 model and evaluate the model which is suitable for prediction and which model is best for our prediction. Let's describe some problem statement. New York is riddled with one ways, small side streets and an almost incalculable number of pedestrians at any given point in time. Not to mention the number of cars, motorcycle and bicycle clogging up the roads. Combine this with a mad rush to get from point A to B, and you will find yourself late for whatever you need to be on time for. To determine which route is the best one to take, we need to predict how long the trip will last when taking a specific route. Therefore, the goal of this playground competition is to predict the duration of each trip. In the test dataset, given the start and end coordinate. Let's begin with our code. Let's import some library, that is NumPy, Pandas, Math, Seaborn, Scikit-learn, etc. Let's load our dataset, which is in the drive. Okay. Let's check our data, how it looks. We use df.head. Df is my dataset. .head is a method to check 5 row from data. There are 1.5 million records in our data and 11 are columns. As you can see here, there is no null value and data type of the columns. Let's describe our data using .describe method. Here you can see the minimum value of vendor is 1 and maximum value of 2, which means there are two vendor 1 and vendor 2. Passenger count have 0 minimum value and maximum value. Obviously 0 is the outlier, so we will remove these rows. Okay, then this is our dependent variable trip duration. We have to predict this column. Okay, so this column is our y column and all these column are x column. Let's check if there any duplication in our data. There is no duplicate value and there is no null and any value in our data set. Let's describe our each variable. ID, a unique identifier for each trip. Vendor ID, a code indicating the provider associated with the trip record. Then pick up date time, drop off date time, passenger count. Okay, and here is store and forwarded flag. This flag indicates whether the trip record was held in vehicle memory before sending to the vendor because the vehicle did not have a connection to the server. Y means store and forwards, N means not a store and forward trip. Let's divide feature into categories. One is geographical, second is time related, third is identifier, and fourth is others, that is vendor ID, passenger count, store and forwarded flag. Last is label detail, which is trip duration. This is our dependent variable. Let's check unique value in each column. Here you can see vendor ID has 2 unique value, passenger count has 10 unique value. Okay, then I give some statement. There are approx 1.5 million record in our dataset. There is no null value and duplicate record in the dataset. The minimum trip duration of 1 second. Obviously 1 second is outlier and maximum is roughly 980 hours. Nobody can travel for 980 hours. So this value also outlier. We will remove these entries. A minimum passenger is 0. Obviously this also is a outlier. Okay. So my initial thought on this matter are that we should extract the hour of the day, week and day of the month, time. We will extract this column from our pickup date time column. I convert date time column from str to timestamp because by default these column are in string format. I use pd.to date time command to convert into date time. Then I split this column into year, month, day and time. Here you can see the function for calculating the distance. Okay, then I create column distance, direction, trip in minutes, average speed, and I create another column which is pick up cluster and drop off cluster. The purpose of this code is to create a single NumPy array that contains both pickup and drop coordinate, which can be useful for various geospatial and data analysis tasks. It is common to combine related column in this way to simplify data handling and processing when dealing with geographical data. Okay. Then I create a copy of my data because I don't want to change my original data. That's why I create a copy. Then I check unique value in each column, how many unique value and what are the unique values in each column. Let's remove some outlier. We give some hypothesis that there must be at least one passenger on board. The distance covered in a trip cannot be less than 500 meters. If it is, it could be an indicator of trip cancellation. The trip cannot be start from out of city. The trip duration cannot be less than 1 minute. If it is, it may be due to trip cancellation. The taxi trip duration cannot exceed 2 hours. If it does, it may be due to traffic delay or maybe some outlier. Let's remove these outliers. I create a function. The overall purpose of this function is to create summary table for different categorical variables in the dataset, including trip counts and means of other numerical attributes for each category. It provides a way to analyze and compare the data across different groups or categories. So here you can see there are 65 entry with count of 0 passenger and 8 and 9 and 7. So we will definitely remove this entry because these not too much entries, only 65 entry there are. Okay. Then you can see here also passenger, the most of the trip are with passenger 1. Okay. Then I check the row which have 0 distance. There are approx 6000 rows in my data set where distance is 0. I will assume this may be outlier, so I will remove these rows. Okay. Then I use this command for trip duration to categorize into different bins. There are few entry about 20 hour with 3.9 mean kilometer. Nobody will travel for 20 hour, only for 4 kilometer. Either there is a heavy traffic or these are outlier. There are few entry in below 1 minute and above 2 hour. Overall, we will remove these entries. Okay. Sorry. Then I give some statement that is vendor 2 has the highest number of trips. The majority of trips are taken by a single passenger. However, there are outlier with passenger count below 1 and above 6. It is reasonable to assume that a taxi cannot accommodate more than 6 passengers. We have the option to either remove this entry or replace the outlier with the mean passenger count. So we will not replace, we will remove these entries. Also, vendor 1 appear to have the lowest number of trips when the passenger count exceeds 4. This could suggest that vendor 1 might have a fewer 7-seater taxis compared to vendor. From store and forwarded flag table in vendor 2, there are no recorded trip with Y flag. This may indicate that vendor 2 is not storing and forwarded trip. Vendor 1 also has a relative fewer recorded trips, suggesting a lower overall recording of trips. The highest number of trips occur in third month, but there is a significant variation in trips across different months. So these are our basic analysis. Okay. Then I give some statement. As you can see, trip count increased significantly in the evening 6 p.m. to 10 p.m. and decreased after midnight 1 a.m. to 6 a.m. Trip count are lower on Sunday and Monday, but higher on Friday and Saturday, indicating differences related to weekdays and weekend. Most trips are not about 30 km with a notable number of very short trips. Let's delete some column. I delete ID, pickup date time, drop of date time, pickup year, because this column is not useful for any analysis, and pickup date time and drop of date time. So also we don't need drop of date time. We will calculate trip duration. This is dependent variable, and we already converted this column into different column, that is month, days, time. Let's visualize this data into chart. As you can see, vendor 2 have the highest trips. Okay, and with passenger 1, the number of the highest trips with passenger 1. And we also check month-wise count. March month have highest count of the trips. Then I check day-wise count. Also I checked time wise count. Here you can see most of the trip from 6 p.m. to 10 p.m. I give some statement. Vendor 2 has more trip compared to vendor 1. Most of the trip are not recorded and not sent to the server. Most of the trip are taken by single passenger. We can have more trips. Most of the trip occurred in 3rd and 4th month. Most of the trips occurred 6 p.m. to 10 p.m. and lowest in 4 a.m. So this is analysis in chart. Also, this is a heat map to check the relation between variables. As you can see here, the distance. Let's check trip duration and distance. That is 0.71, which means distance is highly related to trip duration. Then I check hypothesis testing. As you can see, this data is before removing outlier, and this data is after removing outlier. Here you can see these are outliers in my data set. So these are hypothesis statement for our data. Then I did feature engineering and data pre-processing. I handle missing value, outlier. We already remove outlier. Let's transform our data. We have to transform the column of store and forwarded flag because this is a textual column. We have to convert into two columns, one for n and one for y. Let's remove some column that is not useful for our prediction because the average speed, pickup cluster, drop of cluster, trip in minutes and average speed are kind of dependent variable. Okay, let's define our y data. Y data is trip duration. To train our model, we have to split into x and y column. Y have trip duration, x data are without trip duration. Let's split our data into train, test and test data. We divide it into this data 70% and 30%. 70% data are in the training and 30% data are in the testing. I choose this ratio because it is a common practice in machine learning to split the data into larger portion for training, 70%, and to ensure the model learns from a substantial amount of the data, and a smaller portion of testing, 30%, to evaluate the model performance on unseen data. This helps in assessing how well the model generalizes to new unseen example and provides a good trade-off between training and evaluation. Let's implement our model. First, I define some function. This function to evaluate matrix, which is used to calculate the display various evaluation metrics for machine learning models performance. This code computed evaluation metric including mean squared, root mean squared, R2 square, and adjusted R2 square. The code generates a line plot to visualize, compare the first 100 value of the predicted and the actual y. Then I define another function. This function is useful for understanding which feature have the most influence on a machine learning model's prediction. It calculates and displays feature importance in a sorted tabular format and provide a visual representation of the top 10 important feature using a bar plot. Let's first use linear regression. This code initialize a linear regression model fit to the training data, calculate the R-squared value for the training data, and then use the training model to make prediction on both the training and test dataset. The R-squared value provide an indication of how well the model fits the training data, and the prediction on the test data can be used for evaluating the model's generalization performance on unseen data. Let's explain this model into chart. As you can see, the adjusted R2 is above 50%, which is not too good and not too bad. We also check on test data. On test data, it is 42%. So this is not good. Okay, let's check in the decision tree. The above code you so is for hyperparameter tuning for a decision tree regression model using a grid search technique. After executing this code, the decision tree grid object will store information about the best hyperparameter and the best performing decision tree regression model based on the R squared square. We can access these results using decision tree grid params. Then I use this code. The above code take the best decision tree regression model obtained from hyperparameter grid search and uses it to generate prediction on both the training and test dataset. This is common practice in machine learning to assess how well the optimized model generalizes to new unseen data. So let's check in graph. Here you can see in trained dataset it is 77%, which is good, and in test dataset it is 75%. This is also good. So we can say that decision tree is not too bad to train our model. Okay. Also, let's check feature importance. Here you can see, according to the chart, distance is the primary independent variable that has the most significant impact on the dependent variable, followed by time, pickup day, and direction. Okay, so let's train our random forest regressor. We will have the param grid dictionary defined, which can be used in conjunction with technique like grid search or random search to explore different combination of hyperparameters for our random forest regressor model. The value in the param grid can be further customized to fit the specific requirement and goals of modeling task. The above code initialize a grid search for hyperparameter tuning for the random forest. This code perform a grid search to find the best hyperparameter for the random forest model. Overall score, the best score is 79%. Let's explain this model. This is also good as compared to our previous model. As you can see, 85% score on trained dataset and on test dataset is 79%. Okay. Last is not last. It is XGBoost. The purpose of defining the hyperparameter grid is to systematically search through these specific hyperparameter combination to find the best set of hyperparameter that optimize the performance of the XGBoost model during training. As you can see, the best score is 81.81%. Let's check in graph. 85% accuracy on training dataset and 81% on test dataset. And we also check again the column which is highly related to dependent variable. Sorry. As you can see, distance, time, pickup day, and direction as are the most highly related is distance column, then followed by time and pickup day. Then last model is our gradient boost. Here you can see the train on the train dataset, the result is 74%, and on the test also is 74%. Let's analyze all these 5 models. I create 2DF for train and test dataset. Then I use Seaborn to visualize above 2 data frame into chart. As you can see, different model comparison. Here you can see the best score. The minimum error in our model is XGB or RF. LR means linear regression. Okay. RF means random forest, gradient boost, XGB boost, and decision tree. So these chart on the training dataset and these chart on the test dataset. In both dataset, XGB is best model for our dataset because it have least error. It is good algorithm for this dataset. Let's explain the model. Finally, it select XGB boost as a preferred algorithm due to its lower error, making it a suitable choice for the given data. Last, I give some conclusion. In summary of